Yes, bete. In the last class, I had given you introduction for geometric progression. Now today's task is to solve some more questions based on geometric progression. So let us start some more questions. See a question, fifth question, first part, it is given 2, next term is 2 root 2, then 4 and so on. Which term is 128? Which term of this progression is 128? So let us see. First term of the GP is 2 and common ratio R is second term 2 root 2 upon first term 2. Good, right? 2 to the power 1 by 2. Now nth term means an. The formula for nth term is a r to power n minus 1. A r to the power n minus 1. So an is 128 is equals to a is 2 and r is 2 to power 1 by 2 to whole power n minus 1. So I could write, now we need to simplify it only for n. So let us go for it. 2 to power 6 is equals to 2 into 2 to power n minus 1 by 2. This 2 to 1 power will get cancelled. Now we are simplifying it over here. 2 to power 5 is equals to 2 to power n minus 1 by 2. So n minus 1 by 2 will be equals to 5. N minus 1 will be equals to 10 or n will be equals to 11. So 11th term of this geometric progression will be 128. 11th term of this geometric progression will be 128. Next question. See one question. Question number 7 I'm taking. Okay, before this, I must take question number 6 also. It's simple, but still minus 2 by 7 x minus 7 by 2 are in geometric progression. These are in GP. These are in GP. We have to find the value of x. We have to find the value of x. So as I've taught you in the previous class that geometric mean is the square root of product of the outer two terms, means minus 2 by 7 into minus 7 by 2. So minus to minus cancel, each term to each term cancel. So it gives us square root of 1, that is 1. The value of x in this geometric progression is 1. Next, now question number 7 I'm taking. It is 0.15, 0.015, 0.0015, and so on. We need to find 20th term. We need to calculate 20th term. So for calculating 20th term, we have got first term as 0.15 and common ratio R is 0.015 on 0.15. So it will be 1 upon 10. Term will be 1 upon 10. Common ratio. Now we need to find 20th term. So formula for 20th term, an is equals to a r to power n minus 1 and n is given as 20. So a 20 will be equals to a, that is first term 0.15, common ratio 1 upon 10 to whole power 20 minus 1, that is 19. Now they might give it into the simplified form. Sorry, we have to calculate sum. So in the next slide, I'll find sum also. 15 upon 100 into 1 upon 10 to power 19. I could write it 15 upon 10 into 10 to power 20. 100 I've written 10 into 10, 110 I've taken in 10 to power 19. So answer is 3 by 2 into 10 to power 20. This is the 20th term. Now we need to calculate sum of 20 terms. So SN formula we need to apply. We know that the formula for sum of n terms, we know that the formula for sum of n terms is Sn is equals to A. Now just try to see what is the value of R. The value of R is 1 upon 10. This means it is less than 1. So formula 1 minus R to the power n upon 1 minus R. Hope you remember, if R is less than 1, we need to apply this formula. So A is 0.15, 1 minus R. R is 1 upon 10. A is 0.15. 1 upon 10 to whole power 20 upon 1 minus 1 upon 10. Now we need to simplify it. Let us simplify. 15 upon 100 after removing the point. I could write it taking LCM 10, 10 minus 1, 10 to power 20, 10 to the power 20 minus 1. So it will be 15 upon 100 into this 10 upon this one 9 into 10 to the power 20 minus 1 upon 10 to the power 20. Now we could simplify. 5 by 3 into 10 to the power 20 minus 1 upon 10 to the power 21. Rest answer may be different as per whatever I have solved. Maybe they are not changing 0.15 into fraction. So that could be there. So that much you have to see. As the answer is required, you need to solve the question in the same manner. But main technique to solve the question is this. Now next, one of the very important question, very good question from the exercise. This is sigma, that is summation k is equals to 1 to 11, 2 plus 3 to the power k. We need to find the sum of these terms. So let us find the sum. Let us open 2 plus 3 to the power 1. Next term will be k will be 2. 2 plus 3 to the power 2. 2 plus 3 to the power 3 plus dot dot dot. Last term will be 2 plus 3 to the power up to 11 we need to go na. So 11 will be the last term. Now let us see, first part is 2 plus 2 plus 2 plus dot dot dot. These are 11 terms. Plus 3 to the power 1 plus 3 to the power 2 plus 3 to the power 3 plus dot 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 plus 3 to the power 11. Just try to see, this is the geometric progression. This simply we can add, or this one is also geometric progression. Like 2 to 2 is AP as well as GP. 2 to 2 is AP as well as GP. So I'm adding simply 2 11 times I'm adding. So 2 into 11, it will be 22 plus sum of 11 terms. First term is 3a r to the power n, that is 3 to the power n, n is 11 minus 1 upon 3 minus 1. So answer is 22 plus 3 upon 2, 3 to the power 11 minus 1 is the answer. It's not tough, but for the students, those who are solving first time, it may create some confusion. So that's why I have solved this question also. In the last class, we were talking about sum of the three terms of geometric progression is, sum is given 39 upon 10 and their product is given 1. Find the common ratio and the terms. I've told you in the previous class, whenever in a question, teacher is asking us sum and product, then three missing terms, we have to take A upon R, A, R. These are the three missing terms in the case of sum and product is given for the three terms. So let us solve. Sum means, okay, first of all, I'm taking product. A upon R into A into AR will be equals to 1. Product of three terms is multiplying these three terms. R to R will get cancel. Sorry, R. So A cube equals to 1. That gives me A equals to 1. So the value of A in this case is 1. Now the sum A upon R plus A plus AR equals to 39 upon 10. The value of A is 1. So 1 upon R plus 1 plus 1R equals to 39 upon 10. 1 I'm taking on other side and rest I'm taking LCM. R 1 plus R square is equals to 1 I have taken this side, minus 1 minus 1, it will be 29 upon 10. So cross multiply, 10 plus 10 R square is equals to 29 R. Now this gives me a quadratic, any quadratic equation, 10 R square minus 29 R plus 10 equals to 0. So a quadratic equation is ready. We need to factorize it. 10 R square minus 25 R minus 4R plus 10 equals to 0. So 5R, 2R minus 5 minus 2, 2R minus 5. So the value of R is coming either 5 by 2 or 2 by 5. Now the three terms will be, we need to put the value of R also. We need to put the value of A and R into the three missing terms of geometric progression. A is 1 and R is 2 by 5 or 5 by 2. The value of R is 2 by 5 and 5 by 2. This I am putting in the next slide. So the three terms were A upon R, A, AR. A is 1. 1 upon R is 2 by 5. Then A is 1. Then A into R is, sorry, A is 1. R is 2 by 5. So it gives me 5 by 2, 1, 2 by 5. The first geometric progression when the common ratio is 2 upon 5. When the common ratio is 2 upon 5. Now I'm going for 5 by 2. So it will be A, that is 1 upon 5 by 2. Then A is 1. Then A is 1 into R is 5 by 2. So the three terms will be 2 upon 5, 1, and 5 upon 2. So the two GPs are ready. Means from left to right or right to left we are going, it remains GP. In AP also this was the technique. From both sides it remains arithmetic progression, and in this case also it remains geometric progression. So hope we are able to understand this question also. This is a good and important question. I suppose each one of you will be able to solve this question. It's a good question. Soon I'll send you the video of this question also, but please practice it nicely, then only you will be able to do this question. Now I am solving 17th question. Exactly, I'm taking whatever I feel is a good question. If more questions you want to ask, don't worry, you can send your doubt or problem one question. I'll solve that also. 17th, I'm taking, this is if the 4th, 10th, and 16th term of geometric progression are x, y, z. 4th term, 10th term, and 16th term of the geometric progression are x, y, and z. Prove that x, y, z are also in GP. So, what best I could do with this question? Fourth term means a r to the power 4 minus 1, a r to the power 3 is equals to x. 10th term, a r to the power 9 equals to y. 16th term, a r to power 15 equals to z. So we have got idea what x, y, z are exactly. Now we need to prove x, y, z are in GP. If x, y, z are in GP, then y square must be equals to xz, or y must be equals to square root of xz. So let us calculate. Y is equals to x. X is a r3 and z is a r15. In multiply, powers will get added. In multiply, powers will get added. So a square r to the power 18, that is, when we'll do square root, it will become a r to the power 9, and a r to the power 9 is y. That only was the task to prove. So we have got that x, y, z are also satisfying the condition of geometric mean, or they will be in the geometric progression. X, y, z are also in GP. So it was also a good question. 18th question I'll do in the next class. 19th I'm solving. Find the sum of and find the sum of the products of corresponding terms of the sequences 2, 4, 8, 16, 32. Another sequence is 128, 32, 8, 2, 1 by 2. Listen the words. Only words might create some confusion. Otherwise, question is very good and easy. Find the sum of the products. We need to find the sum of the products. We need to find the sum of the products. So find the sum of the products of corresponding terms of sequence means sum of the products. So first of all, we need to find the product of the corresponding term. Mean first term multiplied by first term, second terms multiplied by each other, third terms must be multiplied by each other, likewise fourth terms and fifth terms. So it will be 2 into 128, 256. 32 into 4, 128. 8 into 8, 64. 16 to 32. 32 into 1 by 2 will be 16. Now we need to find their sum. Once this question was given in the exam, the child has done this much and then the child has added directly. But you have to use geometric progression. Now first term will be 256 and common ratio r will be second term upon first term, 128 upon 256, that is 1 by 2. We need to find their sum, means sum of 5 terms, S 5 will be equals to A 1 minus r to the power 5 upon 1 minus r. We are able to see first term and common ratio is less than 1. If the common ratio is less than 1, we need to apply this identity. So A is 256, 1 minus 1 by 2, 2 whole power 5 upon 1 minus 1 by 2. We'll simplify it and we'll be getting the final answer. So you have to only calculate the sum. Rest, hope completely I've solved this question. It was very easy, and I suppose everybody will be able to do this question. So these are few questions which we could solve. Now again, what all I have taught you. First question was, a sequence is given to us. We need to find which term will be 128. So for that, first term common ratio we have written, and only we need to apply it into the formula. Means questions are very easy, direct questions till now we are solving based on only formulas, identities which you are knowing very well. Same ways, this was these three terms in the geometric progression. We need to find the value of x. So x will be said as the geometric mean between minus 2 by 7 and minus 7 by 2. So x will be product, square root of product of the outer two terms. So square root of product of two terms. I have multiplied the two terms. On multiplying, I am finding the product is coming 1. So after calculating the square root of 1, that remains 1 itself. So the value of x has come as 1. Up to the 20 terms. But first of all, we have calculated 20th term. After calculating the 20th term, we have calculated its sum. So mainly the question was this only. Only a key point is whenever r is less than 1, we need to apply the sum formula this. If in case r is greater than 1, Sn will be equals to a r to the power n minus 1 upon r minus 1. Don't make this mistake. And yes, if in case r is in variable, if in case r is in variable, then you need not to be worried that which formula you have to apply. You can apply directly this formula. There is no problem. Then this question was given. It is one of the very good question. We have been